Welcome to this Sofema Aviation Services video instruction course on Introduction to Regulation EC 1321/2014, the regulation for continuing airworthiness, including Part M and subparts. This diagram shows the two main covering regulations for airworthiness under the basic regulation of EASA. We have already covered 748/2012 initial airworthiness, or Part 21. Regulation 1321 is a covering regulation for 8 annexes containing the regulations for different parts of continuing airworthiness requirements. For example, EASA Part M, continuing airworthiness requirements, Part 145, maintenance, Part 66, certifying staff, and Part 147, technical training. In this course, we are going to be concerned with the contents of Annex 1, Part M, Annex 2, Part 145, and Annex 5C, Part CAMO. And here we have the structure of the basic regulation, and underneath it, Annex 2, airworthiness, and we'll be starting with Annex 1 of 1321, which is Part M, continuing airworthiness requirements. Part M identifies the role and requirements of continuing airworthiness management, which amongst many activities includes the organizational responsibilities, ownership and control of the aircraft maintenance program, and the need to manage the status of life-limited parts, components, and the status of airworthiness directives. Part M of the regulations covers all of the technical requirements related to ensuring that an in-service aircraft and all its components are kept to the same level of airworthiness as originally designed and certified under Part 21. There are 9 subparts to Part M as shown here. It contains requirements for the operations of both the maintenance and CAMO organizations, including required personnel, facilities, documented processes, control of maintenance data, and the rules for certifying aircraft as airworthy and releasing them to service after maintenance. Subpart B, accountability. By organisation in this, we mean maintenance and CAMO organisations. This subpart concerns management accountability and the need to appoint a person with the necessary authority and seniority to manage the organisation and the resources, the availability of funds to ensure overall compliance with the regulatory requirements. In addition, this part deals with the need of the organisation to report any findings such as malfunctions or defects to the regulatory authority. The typical findings that we need to report are detailed in AMC 20-8 occurrence reporting. Subpart C is all about continuing airworthiness and concerns the requirements to perform maintenance and inspections in accordance with the aircraft maintenance program. Secondly, the requirement to rectify defects and damage occurring in service, and the requirement to analyse and implement maintenance and modifications related to airworthiness directives. Lastly, the requirement to manage the effectiveness and measure the effectiveness of the maintenance program by implementing a reliability program. Here we have the chart of Subpart C, Part M. You can see that the continuing airworthiness tasks, which are under Regulation MA 301, basically extend from line maintenance activities on the left. You can see in the green there, pre-flight inspections and servicing. Along to the right, where we're talking more about documentation activities carried out by the CAMO, including measuring the effectiveness of the AMP through the reliability program, analysing and scheduling airworthiness directives for incorporation, accomplishing any required modifications, either mandatory or optional, weight and balance data, and performing maintenance check flights. So all of these activities come under Part M, Subpart C. Some of them are done by the Part 145 organisation, shown in green there. That's the line maintenance activity. And the CAMO is focused on the compiling of the scheduled maintenance based on the maintenance programming document and the aircraft maintenance program. Subpart D is all about using the correct data, people, tools, and facilities to perform aircraft maintenance. That is to say, licensed engineers, fully calibrated tools, and hangars to protect the aircraft. So the need to use applicable maintenance data that relates to the aircraft type and the methods as defined by the type certificate holder, including all the manuals and airworthiness directives. It includes the requirement for persons performing maintenance to be properly qualified and to utilize the appropriate tools and hangar facilities, including lighting and proper tool control. Secondly, there is the need for independent inspections after carrying out critical maintenance tasks, and this is also covered in Part 145. Subpart E relates to the continuing airworthiness of components, and we have the definitions here of serviceable, unserviceable, and unsalvageable, which relates to life-limited parts that have expired their life. Only parts that are both serviceable and identified in the maintenance data as being applicable for the aircraft configuration are to be fitted to the aircraft. There's a requirement for standard parts to be traceable, have a certificate of compliance, and have part marking, and requirements for component maintenance and the control of life-limited parts. Serviceable components come with a EASA Form 1 Certificate of Airworthiness. Subpart F differs from a Part 145 organisation, although it also relates to maintenance organisations. It can only release smaller types of non-commercial air transport aircraft to service, but it is similar in many ways to a Part 145. So the requirements under Subpart F, in order to qualify for an approval as a Subpart F maintenance organisation, there are a number of things that need to be developed and complied with: a maintenance organisation manual, facilities, equipment and tools, personnel including licensed engineers to certify the aircraft and also airworthiness review specialist staff, use of data to control maintenance activity, work orders and maintenance manuals, the process for certificates of release to service and components and aircraft, maintenance record keeping requirements, the privileges of the organisation which relate to its approved scope of services, regular review of the organisation, and correction of findings of non-compliance. So it's the QA or quality functions, or compliance functions as we call them now. So Subpart F doesn't relate to maintenance of large aircraft or commercial air transport. That would require a Part 145 approved organisation. It also doesn't have any concept of line stations under Subpart F. Continuing Airworthiness Management Organisation, CAMO, is covered under Subpart G. The requirements to be met for an organisation to qualify as a CAMO include the extent of the approval, the requirements to develop a Continuous Airworthiness Management Exposition, or CAME. The CAME contains all of the details of the organisation's structure, personnel including nominated persons, continuing airworthiness procedures, the quality system, and the rules for contracted maintenance. We have the personnel requirements for the CAMO. The CAMO personnel should have adequate knowledge of the design status, that is to say, the type specification, customer options, airworthiness directives, airworthiness limitations, and other data contained in the particular aircraft's instructions for continued airworthiness. This would also include modifications, major repairs, and operational equipment. The status of aircraft design and maintenance should be adequately documented to support the performance of the quality system. There are actually a long list of responsibilities for a CAMO organisation concerned with the management of the aircraft maintenance programme and the planning of all required maintenance. Subpart G, continued. Continuing airworthiness management responsibilities and functions can include the following: development and control of the AMP, monitoring of effectiveness of the aircraft programme, which is the reliability function, reliability monitoring, management of modifications and repairs, optional service bulletins, mandatory service bulletins, and damage-related repairs, Planning and tracking of required maintenance, the tasks that are scheduled in the maintenance programming document and then in the AMP, known as last done, next due, incorporation of AEDs, tracking and resolution of aircraft defects, and this is performed via the Part 145 organisation, or Subpart F, scheduling and planning of base maintenance checks via the maintenance organisation, and also management and retention of all continuing airworthiness records. So the CAMO's got a large responsibility to schedule, plan maintenance, keep track of the state of the aircraft in terms of any mandatory bulletins and ADs, and keep all the records. So here we have it. There's an overview of the CAMO activities. An airworthy aircraft needs all these things to be happening around it, needs ADs to be incorporated. The AMP needs to be sound and fully suitable for the aircraft's operation. Technical log needs to be completed regularly and up to date. There's a whole lot of factors which go into the control of the CAMO. This shows the interfaces between the CAMO organisation, Part M, Subpart G, and the maintenance organisation, and also the operator. On behalf of the operator, the CAMO will monitor maintenance program for due maintenance tasks. It'll keep track of all the scheduled tasks in the AMP. It'll keep track of any ad hoc bulletins and airworthiness directives that have a drop dead date or a threshold date. And it will implement them into a package of work, such as a C check or an A check or other activities which take place between those checks in the form of a contract or work order. The maintenance organisation receives the work order and acts upon it, gathers together the requisite maintenance data to perform the tasks listed in the work order, performs the tasks, and then feeds back the completed work cards to the CAMO, so the CAMO can keep track of what maintenance has actually been accomplished. Also involved in this process are Part 21 design and manufacturing organisations, which need to support such activities as modification programs and major repairs. Release to service is carried out or defined under Subpart H of Part M, and it concerns who can sign a certificate of release to service and the options available for certification on an AOG, aircraft on ground basis. The CRS has to be issued always by certifying staff of the Subpart F or Part 145 maintenance organisation. The operator or the CAMO cannot issue certificates of release to service. Subpart I is a primary CAMO function, and it relates to airworthiness review certificates or ARCs. The ARC is a certificate of airworthiness which is non-expiring but is validated annually with the airworthiness review certificate. An ARC review is performed annually, and a full in-depth ARC takes place every third year. So the ARC review can be performed by qualified personnel in the CAMO who have the Part M Subpart I approval. Basically, the ARC review entails a very detailed documented review of the aircraft records, so a desktop review or looking on the maintenance records computer to check the status of the aircraft with regard to maintenance, and also a physical survey of the aircraft in a flight-ready condition. The review of the technical records will usually be performed remotely by the CAMO and will involve these activities: sampling of aircraft maintenance program tasks, checking of the AD compliance status, verifying that hard time components have been replaced when required, and modifications for compliance and certification have been carried out. Also, any repairs necessary for compliance with airworthiness. We're now going to move on to the Part CAMO regulation. Part CAMO is found in Annex 5C under Regulation 1321/2014. This is basically a new type of CAMO organisation to replace the one that we've previously looked at under Part M. Part CAMO is actually a separate annex to the regulation under 5C and establishes the requirements for an organisation to be able to carry out continuous airworthiness management on behalf of an operator, including requirements for qualification and privileges. The existing requirements of Part M, Subparts F and G, for continuous airworthiness management have now been moved into Part CAMO. So organisations that were previously approved under these subparts need to reapply and be approved as Part CAMO organisations. So Part CAMO contains a management system. This is the difference from the previous Part M system for continuous airworthiness management. It introduces the concept of a management system including safety management, SMS, and compliance monitoring, which we used to call the quality management system. So Part CAMO introduces a safety management system into the integrated management system of its organisation. So we mandate the organisation to clearly define accountabilities and responsibilities, to establish a safety policy and related safety objectives, implement safety reporting procedures in line with just culture principles, ensure the identification of any aviation safety hazards entailed by the activities carried out by the CAMO organisation, and the analysis of those risks and the mitigation of them. The monitoring of compliance with a separate compliance monitoring function under a compliance monitoring manager, which is there to regulate compliance with the established procedures and regulations. Also, there's a requirement to keep personnel trained, competent, and informed about significant safety issues. And lastly, to document all of the key management system processes. So this is simply called the management system and includes functions such as compliance monitoring, previously QA. It is similar, but not absolutely identical to the management systems required for the Part 21 design organisations. EASA is now requiring that SMS is introduced into any management system for any aviation operation, whether it be Part 21, 145, CAMO, flight training, ATC. So it's a universal standard, really, the safety management function. And here we have the basic pillars of the SMS. We've seen them before in Part 21, including the safety policy, a process to identify hazards, mitigate them, safety reporting system, and a process for monitoring the performance of these activities. So yeah, that's the drawing of the CAMO SMS. It's the same as any other SMS. It's a closed loop activity of constantly assessing emerging hazards in the organisation, coming up with suitable mitigation actions and safety solutions, implementing them, and then monitoring their effectiveness. So it's a continuous cycle of keeping aware of hazards, addressing them, and then tracking to see how well you're doing. Internal compliance monitoring, formerly called QMS, Quality Management System, is employed to ensure that the organisation remains fully compliant with the EASA regulations, as well as the organisation's own requirements, as laid down in its operating manual. In all CAMO organisations, a full compliance management system is required regardless of the size of the organisation. A CAMO can be approved without the capacity to conduct airworthiness reviews, which can be subcontracted. A CAMO or its subcontracted organisation does not have to be linked to or be part of an airline operator AOC holder, as long as it meets the requirements in terms of process, personnel, and management system, and is also competent on the aircraft types operated by that airline. This shows a minimal CAMO organisation structure with, in this case, airworthiness review privileges. There's an accountable manager, a separate compliance monitoring manager, a separate safety manager, and a nominated person for continuing airworthiness. So there's basically 4 nominated personnel there, Plus, underneath that, you've got staff that are qualified to do airworthiness review and ARC reviews, and the general CAMO personnel. So that's a basic organisation. A larger one, a more complex CAMO would integrate functions such as in-house planning, engineering functions, technical services, or even the Part 21 activities, but low Part 21 is a separate approval. Reliability and maintenance operations control, or maintenance control functions for managing aircraft remotely, inline maintenance. Of course, these can be outsourced to other approved organisations by smaller CAMO companies, and often is. Reporting requirements. To comply with the Regulation 376/2014, as well as the mandatory occurrence reporting process, we have to establish an internal safety reporting scheme within the organisation to collect and evaluate occurrences, errors, hazards, near misses, that sort of thing. So really, the internal safety reporting scheme forms part of the organisation's SMS and is set up to record all potential indicators of safety issues. And this would include items such as aircraft defects found during inspections, maintenance errors, for example, parts found incorrectly installed or missing, errors in technical instructions and work cards, excessive deferred defect rates, on-ground occurrences and incidents during maintenance and aircraft movements, injuries to personnel, quality audit findings, and airborne incidents of any nature, including heavy landings, structural damage, and engine and systems failures. Typically, these are collated within a single database administered by the safety manager. So subcontracting can be carried out by the part CAMO, but when the organisation subcontracts any part of its continuing airworthiness management activities to another organisation, that organisation shall work under the approval of the CAMO. So the part CAMO organisation shall ensure that the competent authority, that's to say the National Airworthiness Authority that looks after compliance with regulations in the particular state, is given access to the subcontracted organisation to determine continued compliance with the applicable requirements. Facilities are important. Suitable office accommodation, appropriate locations needs to be provided for the personnel performing the CAMO functions. The CAMO has a detailed responsibility for keeping records. The airworthiness records referenced in Part M, MA 305, are termed the Aircraft Continuing Airworthiness Records System, and this includes the current lives of time-controlled components and life-limited parts, compliance with the maintenance program, as we said before, last done and next due, detailed maintenance records from the Part 145 organisation, that's work card records and reports, information related to implementation of airworthiness directives and service bulletins, modification and repair records, inspection defect records, aircraft technical log pages, which is the MA 306 requirement for commercial air transport operations, component and aircraft release to service, and also if the CAMO has airworthiness review certification extension privileges under CAMO A125, copies of the ARCs and related reports. Normally all of this, or most of this, will be kept on a ERP IT system, some kind of maintenance records database, but inevitably there will also be records which are kept in paper copy. The next subject is a look at Part 145, which is continuing airworthiness in a maintenance sense. The requirements for Part 145 are found in Annex 2 to Regulation 321/2014. There they are. EASA Part 145 is concerned about the actual performance of maintenance, whereas EASA Part M and Part CAMO is all about the management of maintenance, the scheduling of maintenance and control of it. This is because it's more correct for the operator to be responsible for the management of the status of maintenance on its aircraft, although the operator may be working indirectly through the Part CAMO organisation. This simplifies the responsibility of the EASA Part 145 organisation just to focus on the actual delivery and certification of the requested maintenance package. For maintenance of aircraft which are classified as complex motor-powered aircraft, or CMPA, Part 145 maintenance approval is mandatory. For licensed air carriers, regardless of the aircraft designation, Part 145 approval is also mandatory. So airlines need to have a Part 145 to service their aircraft. For all other aircraft, such as private business jets and light commercial aircraft, it's possible to choose between a Part 145 maintenance approval or go to a combined airworthiness organisation maintenance approval. What are the key aspects of gaining a Part 145 approval? There are a number of things that need to be in place before EASA will accept the maintenance organisation as approved for Part 145. Firstly, facilities. These must be appropriate to meet the environmental requirements and sufficient for the work being carried out. There needs to be enough manpower to do the work with suitable competencies. Documentation, maintenance data has to be the current data, appropriate data for the aircraft type, and fully approved. Process and procedures. The organisation needs a fully documented maintenance process in its MOE, Maintenance Organisation Exposition. Tooling and equipment, an essential part of a maintenance organisation required to support the maintenance activities. There needs to be a quality assurance process, although it's probably these days called the compliance process, to ensure continued compliance with the regulatory and organisational requirements. A production planning function is essential. This is a group of specialist planners who have to plan and coordinate the required maintenance so that it happens on time and to the right quality. Production planning and maintenance planning are two essential aspects of airworthiness and aircraft maintenance in the aviation industry, especially in organisations that comply with the EASA format. Whilst having distinct focuses, both of these activities are equally crucial for the smooth functioning of operations. By effectively coordinating these two planning processes, airlines, CAMOs, and aircraft maintenance organisations can optimise their resources, minimise downtime, and enhance safety while staying compliant with applicable regulations and deliver airworthy aircraft. The purpose of production planning in a Part 145 AMO is to effectively manage the processes and resources required for the performance of maintenance of aircraft and/or components according to the instructions given by the CAMO. Maintenance planning, on the other hand, falls under the purview of the CAMO, which focuses on scheduling and coordinating maintenance activities based on an established approved maintenance program, AMP, to ensure the ongoing airworthiness and reliability of the aircraft. The organisation, this is the CAMO, shall provide a common work card or worksheet system to be used throughout the relevant parts of the organisation. Historically, the MRO or AMO may use its own work card system, and the CAMO may have its own work order system, but increasingly they're being merged under a single IT system, a single maintenance control system with digitized maintenance data. So this diagram basically shows the flow of information. The CAMO performs maintenance planning, generates a package of work in the form of a work order listing all the tasks that need to be completed by the maintenance organisation, who then studies those, works out what it's going to require in terms of manpower, tooling, logistics, etc., and time. Quotes a cost back to the CAMO and the operator, and then sets about project managing the maintenance activity. When the maintenance activity is performed, the AMO production planning returns the completed task cards either physically or digitally back to the CAMO for their records. Electronic work orders and task cards are increasingly replacing the paperwork systems from past, although the industry movement on that is still quite slow. So depending on the amount and complexity of work performed by the maintenance organisation, the production planning function may range from a very simple procedure to a complex setup using dedicated function and quite a lot of staff. So there's really two basic functions for production planning. One is scheduling the maintenance work ahead so that it won't adversely interfere with other work going on in the facility regarding the availability of all necessary personnel, tools, equipment, material, data and facilities. And while the maintenance work is actually going on, project managing and organising maintenance teams and shifts and providing all the necessary support to ensure the completion of maintenance without any undue time pressure. So that drawing there shows all the things that the AMO production planning group would be involved with. It's quite a lot of stuff. They're a very important part of a Part 145, basically the brains of the system. They project manage an aircraft from the start of its heavy check all the way through to the end, and also interim maintenance performed online. So there's quite a lot of activities that need to be coordinated and done effectively. Facilities for base maintenance of aircraft. It's important that the aircraft hangars are both available and large enough to accommodate the aircraft that are going to be serviced on a planned base maintenance input. For component maintenance, component workshops need to be large enough to accommodate the components that are going to be going through. Some large items like landing gear, for example, need very large shops. You can see here there's a wheel and tyre bay. So quite often the facilities are segregated. So you normally have a large hangar area with maybe a mezzanine, which has some local supervisory management on it, and probably also used to store interior items removed from the aircraft, such as seats. There are back shops which store and also renovate interior items, monuments we call them, toilets, galleys, etc. And of course the seats and seat belts. Part storage is also an important thing. Storage facility for aircraft components should be clean, well ventilated and maintained at a constant temperature to minimize the effects of condensation. So manufacturers' storage recommendations should be followed for those aircraft components as identified in their published recommendations. The storage racks must be strong enough to hold sometimes some very large aircraft components and provide sufficient support for those components so they are not distorted during storage. And wherever practical, certainly all of the smaller components would be protected with some kind of cover like plastic or anti-static bag. And lastly, the working environment itself must be such that the effectiveness of maintenance personnel is not impaired. In some parts of the world, it can get extremely hot in a hangar, so air conditioning is an important thing, such that the personnel can carry out the required task without undue discomfort. Dust and any other airborne contaminants should be kept to a minimum and not allowed to reach a level in the work area where visible component or aircraft surface contamination is evident. Tooling requirements. The organisation needs to stock up on all the necessary tools to maintain the types of aircraft that it's approved to do so. When a manufacturer specifies a particular tool or equipment, the organisation will have to use that tool or equipment unless the use of alternative tooling or equipment is agreed by the competent authority via procedures specified in the exposition. An important requirement is for the organisation to have a proper tool control procedure for checking out and checking back in tools used in aircraft maintenance tasks. This is an important protocol to prevent tools from being left in the aircraft and causing foreign object damage. Tooling needs to be available at the point of delivery of maintenance. Any shortfalls and shortages should be minimised. The tooling requirement is typically known, or at the very least, the information related to the tooling requirements are known. Waiting for tooling will result in lost time, so it's important that The planning organisation plans ahead for this and makes sure that its tooling required for the particular task is A, available, and B, serviceable, and C, calibrated. Calibration is very important because if an incorrectly calibrated tool is used, it can actually be a flight hazard. With regard to personnel, starting at the top of the organisation, the accountable manager needs to be appointed. And this person needs to have corporate authority for ensuring that all the maintenance required by the customer can be financed and carried out to the standard required by Part 145. The accountable manager is normally intended to mean the chief executive officer or CEO of the approved maintenance organisation. And depending on the size of the organisation, the management functions may then be subdivided under individual managers or combined. So the accountable manager holds a deep understanding, or should hold a deep understanding, of the obligations and expectations of a Part 145 role. He should develop a focus on management system requirements with safety and compliance techniques as required in the EASA Part 145-30. The accountable manager needs to understand the relationship between the compliance management systems and the safety management systems. So he needs a pretty deep knowledge of everything going on in the Part 145 and all the associated requirements. It is, in fact, quite a long list. Regulatory compliance is a responsibility, ensuring that all our operations are conducted in compliance with the relevant standards and regulations. Safety and quality, overseeing the implementation of the SMS and promoting a safety culture, making sure that resources exist to maintain the highest safety standards. Financial oversight, managing the financial health of the organisation, including budgeting and cost control, and particularly ensuring there are enough financial resources to operate safely and efficiently. Personnel management. Personnel have to be trained and qualified for the roles. That needs organising, it needs financing. So these are all the responsibilities, along with others, for the accountable manager. Basically, he's responsible for control of all of the operations and all of the regulatory compliance requirements of the Part 145. So it's a very major role. The second down from the accountable manager will be the compliance monitoring manager. It's basically an independent person whose role is to ensure that the activities of the organisation are monitored for compliance against the regulations and against the organisation's own quality procedures. So these activities, these compliance auditing procedures, are carried out properly under the supervision of nominated persons. So all the requirements regarding maintenance are passed down to sub-level managers. So the activities supervised by those persons have to be audited regularly. We're talking about base maintenance managers and component shop managers and line maintenance managers and staff. So a couple of key points. The compliance monitoring manager should not be one of the persons I've just mentioned that are managing an operational area of the AMO. They should be able to demonstrate relevant knowledge, background, and appropriate experience related to the activities of the Part 145, including knowledge and experience in compliance monitoring. Also, they should have full access to all parts of the organisation in order to inspect it and carry out audits. The compliance monitoring manager manages an audit plan which has a cycle of audits scheduled for each of the departments in the Part 145 to define and also determine whether there are any compliance issues existing in those areas. And if there's any corrective actions required, the compliance manager will make sure they're followed up by the relevant manager. Personnel requirements. Competency. Well, first we need to agree what we mean by competence. This really means that the employee has the necessary technical or specialist training, the background, experience, and knowledge appropriate to his job role. In addition, the employee also understands the company process and procedures which are relevant to that role. In addition to the necessary expertise related to the maintenance job function, the maintenance skills, competence of personnel must also include an understanding of the application of human factors and human performance issues appropriate to that person's function in the organisation. It is generally accepted that the most effective human factors training is training which takes into account specific organisational issues and has a direct connection with the compliance management and safety systems of the organisation. So the human factors aspects, which every employee, certainly all the supervisory employees, but I would say every employee needs to be aware of, are the factors that might influence their performance within the maintenance organisation due to environmental factors, leadership, workload, stress, fatigue. All of those human factors come into the quality of decision making and the quality of communications. So it is quite a sophisticated level of understanding is required of maintenance personnel, including technicians. So apart from the human factors training, there are other mandatory technical training and safety training required. For example, fuel tank safety, all about entering fuel tanks in a safe manner. Electrical wiring integration systems practices, organisation procedures, inspection standards, dangerous goods, and health and safety. So really, we can see from all this that there are two elements to the process of ensuring competency of personnel. First, there is the competency expectation placed on the employee, together with the obligation placed on the organisation to provide appropriate level of training to ensure that the employee has the necessary organisational knowledge. This is the typical organisation structure of a complex AMO. You can see here, depending on the size of the organisation, the Part 145 maintenance functions can be divided under nominated persons or combined in any number of ways. However, a maintenance function cannot be combined with the compliance monitoring function. They've got to be independent. So the maintenance functions include maintenance and safety training, performance and certification of maintenance, equipment and component procurement, facility management, production planning. And it should be ensured that each separate Part 145 maintenance function is attributed to one nominated person. So this is a simplified view of that. At the very least, you've got a workshop manager, a line maintenance manager, and a base maintenance manager, and an NDT specialist manager. And underneath those managers are the relevant technicians. There's also a safety manager, and that's part of the SMS system. So the base maintenance manager is responsible for ensuring that all base maintenance is carried out in the hangar or facility to the standards specified in point 145A65. The base maintenance manager is also responsible for carrying out any corrective actions resulting from the compliance monitoring audits. The same goes for the line maintenance manager. He will make sure that line maintenance is performed in accordance with the documented procedures and also respond to any non-compliances. This is generally the process for each of the managers. Certifying staff. Certifying staff is a person with the appropriate aircraft rated category C, B, or L Part 66 license, who can, in accordance with an authorization secondly delivered by the organization, certify the maintenance that he or she verified or performed with the certificate of release to service. The maintenance tasks which can be certified are only those within the scope of authorization, which is based on his or her license privileges as laid down in Part 66. Certifying staff also include Category A or B2 task-trained license holders who can certify minor scheduled line maintenance and simple defect rectification that they perform themselves. All certifying staff should be listed in the MOE. Support staff means those staff which hold an aircraft maintenance license under Part 66, i.e. a B1, B2, or L, with the appropriate aircraft ratings. But these persons are working in the base maintenance environment while actually not holding certification privileges. So they are fully licensed, experienced people that understand the inspection requirements, but they're not actually exercising certification privilege. The use of support staff with the type-rated B licenses is required during the base maintenance of complex motor-powered aircraft. That's large airliners normally. For base maintenance of other types of aircraft, support staff are not required, but they can be used. The system of certification should ensure that all tasks are clearly managed, stage signed and certified where appropriate by suitable authorised persons. Now, a sign-off authorisation doesn't mean that the authorised person can sign off all of the aircraft maintenance tasks. It means that he or she can sign off tasks up to the authorised level, depending on the training and experience held. Furthermore, even if this person is qualified and able to carry out the task to the required standard, that does not mean that certifying and support staff are not needed. The presence of certifying staff and support staff is an additional safety barrier. So as you can see in this diagram, at the top of the series of activities here, an authorised person, that's a licensed engineer, will carry out a maintenance task and he will sign it off as in accordance with the aircraft maintenance manual. So he's responsible for the direct accomplishment of that task. However, support staff in the form of other licensed engineers will check his documentation and possibly also do a secondary inspection to verify that the work has been done in accordance with the expected requirements. And that support staff person will sign against that. Lastly, when all the information is gathered for all the maintenance activities carried out and all of it has been signed off both by the authorised persons and the support staff, then the certifying staff can verify the overall completion of the maintenance activities. And this is typically done at the end of a maintenance check, where a certifying C licensed engineer will sign off the whole check, the whole C check or A check, based on the verifications provided by the other two levels, by the authorised persons and the support staff. So it's a three-stage check, really, which provides an additional safety barrier. You're not just having the maintenance done by a licensed engineer and signing it and leaving it. There are other people checking that he's done it in accordance with the right data and to the intent of the work card. So what do we mean by the required standard? The required standard for maintenance is that you've done the instructions contained in the task cards. You've used the applicable maintenance data. That's usually maintenance manuals, but also IPCs, component manuals. That the engineer has followed the applicable standard practices and the procedures of the maintenance organisation itself. The certificate of release to service, as just mentioned, is issued before flight at the completion of any maintenance. So at the end of the maintenance check, a CRS would contain the following statement signed by the certifying staff. It certifies that the work specified, except as otherwise specified, was carried out in accordance with Part 145 and in respect to that work, the aircraft or aircraft component is considered ready for release to service. Any new defects or incomplete maintenance work orders identified during the above maintenance should be brought to the attention of the aircraft operator for the specific purpose of obtaining agreement to rectify such defects or for completing the missing elements of the maintenance work orders. So sometimes there may be discrepancies found by the operator. Something may not have been carried out according to the original package, and that would need to be rectified. Maintenance data. The organisation should establish a procedure to ensure that the maintenance data it controls is kept up to date. In the case of operator or customer controlled data, the organisation shall be able to show that it has either written confirmation from the operator or customer that such maintenance data is up to date at the time it was supplied. These days, most Part 4.5 organisations for major aircraft types have moved over to digital data from paper copy manuals, or do so in the next few years. There are some maintenance and component manuals which still can only be obtained as paper copies, but in general, a lot of organisations now are using online information from Boeing or Airbus maintenance databases, which they signed up to as a subscription. And all of the maintenance data can be found there, and it can be downlinked as a PDF file or printed directly from the system, if indeed printing is required, because increasingly maintenance organizations are now using devices, personal devices such as laptops, or more recently iPads, to reference the maintenance manuals. But even for this digital information, somebody needs to keep track of it and make sure that all the latest revisions are incorporated and that the engineers have access to the latest data. So here's some of the maintenance data we're talking about. Everything from the maintenance agreement with the operator to service letters, service bulletins, task cards to carry out the work, reference information, the maintenance program. Mainly the Part 145 organisation will be most interested in things like the maintenance manuals, the task cards, the repair manual, airworthiness directives, and any other thing related to physical work on the aircraft. The maintenance program is something which is really managed by the CAMO. Critical maintenance tasks. The organisation should have a procedure to identify and manage critical maintenance tasks. The procedure should minimise the possibility of an error being repeated in identical tasks and therefore compromising more than one system or function. Now, the types of tasks which may be sensitive to safety are any tasks which may affect the control of the aircraft flight path, such as rigging of flight controls or installation of servos, for example. Anything to do with aircraft stability, such as autopilots or fore and aft fuel transfer systems. Tasks that affect engine thrust, including installation of engines, propellers and rotors. And for helicopters, rigging of the rotor head. Overhaul, calibration of rigging of engines, propellers, transmissions and gearboxes. So all the heavy duty power plant equipment is fairly critical, certainly anything to do with flight controls, and that includes avionics to some extent. So the procedure put in place needs to identify the error capturing methods, needs to list the actual critical maintenance tasks which need to be considered for special inspection. It needs to consider the training and qualification of staff applying the error capturing methods and how the organisation ensures that its staff is familiar with critical maintenance tasks and the error capturing methods. So independent inspection is one possible error capturing method. Well, what is an independent inspection? Well, it's an inspection performed by an independently qualified person of the task carried out by an authorised person. So a qualified authorised engineer performs a task and a second person comes along and inspects it. So the independent qualified person is the person who performs the independent inspection and attests the satisfactory completion of the task and no deficiencies have been found. This person does not issue a certificate of release to service, therefore they're not required to hold certification privileges. So this is where the support staff come in. A licensed engineer can inspect the work performed by the authorised person who is a licensed engineer also. Ultimately, though, the authorised person issues the certificate of release to service. So one engineer goes in, he performs the adjustment and does the work. He inspects it for himself. He's satisfied. He calls in the independent person who performs a second inspection. And when he's happy, the original licensed engineer signs off the certificate of release to service. So the work card system used to document all of this should record both the identification of both persons, their numbers and signatures, and the details of the inspection carried out. And this is done before the issue of the certificate of release to service. But there are plenty of other data sources where you can find data which might point you in the direction of tasks which are in the maintenance manual which need secondary inspection or precautionary examination and special care when they're performed. You can get this information from accident reports, you can get it from investigation and follow-up incidents, flight data analysis, and operations monitoring schemes. So historically, where a particular type of maintenance has been shown to repeatedly cause problems, that would be a candidate for becoming a critical maintenance task. and therefore subject to special inspection. Components. Well, prior to installation of any component as scheduled on the maintenance plan, the maintenance organisation shall ensure that it's the right component, that it's at the right standard to be fitted, particularly when some components have different modification standards related to Airworthiness Directive compliance. The organisation may fabricate a restricted range of parts to be used in the course of undergoing work within its own facilities. This is called manufacture in the course of maintenance. So making minor parts, bracketry, etc., in a sheet metal shop, for example, would be limited scope fabrication. But if you do that type of work, you need to document the extent of it in the maintenance exposition. With regard to removing components that have reached their certified life limit or contain a non-repairable defect, these items should be classified as unsalvageable and shall not be permitted to re-enter the component supply system. Now, to prevent any chance of that happening, a permanent scrapping procedure is required. So what happens there is that persons disposing of scrap aircraft parts should, when appropriate, mutilate those parts and materials prior to release into the scrapping system. So mutilation should be accomplished in such a manner that the parts become basically unusable for their original intended use, and they cannot be refitted to an aircraft either in error or deliberately, which has happened with, unfortunately, in some organisations. So mutilation of the part may be accomplished by a number of methods: grinding, burning, removal of a major lug or other integral feature, permanent distortion of parts, cutting a hole with a cutting torch or saw, melting, sawing into many small pieces. So it's pretty destructive, but it stops that part being put back on an aircraft because it's a dead part, it's expired. Record keeping. Part 145 shall record all the details of maintenance work carried out. As a minimum, it shall retain all the records necessary to prove that all requirements have been met for issuance of the certificate of release to service, including the subcontractor's release documents. The organisation shall provide a copy of each certificate of release to the service to the operator, together with a copy of any approved data used for repairs or modifications, any STCs incorporated, any modifications, any ADs performed. The organisation needs to keep a copy of all the detailed maintenance records and any associated maintenance data for 3 years from the date the aircraft left their hangar, basically, from the date the aircraft was certified as serviceable. The records under this paragraph need to be stored in a way which ensures protection for damage, alteration and theft, not to be put in cardboard boxes in a wet shipping container or a damp hangar corner, need to be properly racked in compactors or in metal containers. This is quite a challenge because manual aircraft maintenance records can be very extensive and very bulky, a lot of paper, a lot of files, and they take up a lot of space in an organisation. This is why we're moving progressively towards digital recording of maintenance activity and having it purely online. But the progression to that is happening fairly slowly because of various the conservative nature of regulatory authorities and also the investment required to digitize all of the maintenance records. Maintenance procedures. Well, the organisation needs to write down all its procedures in the maintenance operations exposition, the MOE, and that document should ensure that in the description of the processes they follow, that human factors and good maintenance practices are always taken into account. These practices need to comply with the Part 145 and Part M requirements. So the maintenance procedures in this document shall cover all aspects of maintenance activity, everything from manpower planning through to logistics, inspection, etc., including the provision and control of specialised services such as NDT or calling in other outside services for inspections, perhaps, or component processes. The MOE procedures are signed off by the competent authority, the National Airworthiness Authority, And basically they all have the same structure. The part one is the organisation structure and general management, accountable persons, etc. Part two is all the detailed maintenance procedures for everything they do. Part three is the management system. Now we're talking about the compliance procedures there and to the safety procedures as well. For the procedures for interfacing with the customers and how customers' data and business requirements are managed, and how information is reported back to the customer. And lastly, there's usually a bunch of appendices which have examples of the various forms and documents used in the processes. Line maintenance procedures. Well, line maintenance is just another form of maintenance, but it's understood as any maintenance that is carried out before flight, immediately before flight, to ensure that the aircraft is fit for the intended flight. It's usually a separate operation within a Part 145 organisation based out on the aircraft gates and the centre part of the aircraft. So line maintenance may include servicing, troubleshooting, defect rectification. If you look at Subpart C of Part M, you can see the breakdown there. It includes pre-flight inspections, walk-around checks, check for leaks, and make sure the tyres aren't flat, remove all the gear and flight lock pins, check the tech log for defects, verify that any deferred defects have not expired. If they have, do something about them, perform servicing, topping up fluids like IgG and oil, and putting pressure in the tyres. So all that kind of general servicing stuff is done by line maintenance, together with defect rectification and fixing any damaged items such that the aircraft can go flying. Reporting of unairworthy conditions. Now, this is about occurrence reporting. So the aim of occurrence reporting is to identify the factors. So it's for our future use, really, in making the organisation safer, such that we don't repeat errors. A certificate of release to service under maintenance is a verification and statement there are no known non-compliances which would endanger flight safety at the point of releasing the aircraft maintenance. So what does endanger flight safety means? It means any instances where safe operation could not be assured or which could lead to an unsafe condition. They might include, but not limited to, significant cracking of structure, deformation, corrosion or failure of the structure, any evidence of burning, electrical arcing, significant hydraulic fluid or fuel leakage, and any emergency system or total system failure. These normally would not be in existence at the time you certify the aircraft for release of service, but they might happen in between and perhaps be discovered during line maintenance. It's also possible for maybe some inspections that are carried out in between the major checks will detect a non-compliance, the condition of the aircraft not being acceptable, or maybe a task was not carried out. However, the intent is not to require the maintenance organisation to find or become responsible for any hidden non-compliances which are not expected to be discovered during the scheduled maintenance programs. So, as I said, the non-compliances of this sort are expected to be detected either during the course of later inspections or during scheduled audits. So the findings that we can have are level 1, which are significant and which directly lower the safety standards and seriously hazard flight safety. A level 2 is any non-compliance with the requirements which could lower the safety standard and possibly hazard. So it's a little less significant or serious than a level 1, but still a thing to worry about. So anyway, after receipt of the notification of the findings, the holder of the maintenance organisation approval shall define a corrective action plan and demonstrate corrective action to the satisfaction of the competent authority. And there's a time limit placed on that. Certainly level 1 findings have to be done within a pretty short time limit. They have a very high priority. The maintenance organisation needs to establish, implement and maintain a management system. This is in addition to the basic structure of accountable personnel. It's a system which defines the accountability and lines of responsibilities of the people we've already talked about, the accountable manager, compliance manager, safety manager, and so on. It will contain a description of the overall philosophies and principles of the organisation regarding its attitude and desire to protect safety. There should be a procedure in the management system for the identification of aviation safety hazards and management of associated risks with mitigation actions. And also another key point is personnel should be trained and competent, as we mentioned earlier. Competency is an important factor in a Part 145 organisation. And also all the processes should be documented in the MOE. So there we have it. That's a standard diagram, if you like, which really applies to all organisations performing aviation activities, also to the CAMO organisations and the Part 21 organisations have this type of management system with those basic 6 factors involved. And there we have again the SMS, which we're familiar from the Part 21 discussions. The 4 pillars of SMS are an important part of the 145's integrated management system. And this SMS should also include a voluntary reporting system internal to the organisation to capture any information related to safety events and non-compliance. It's in fact part of the safety culture to have a voluntary reporting system with a no blame initially, certainly a voluntary system, because we need to encourage the detection of errors that occur, honest errors that occur due to human mistakes made in the course of maintenance. So it's not about blaming the person that reports the error they made or the finding they've seen, but it's about learning and putting that into our safety management for the future so that we don't make those mistakes again. So that's all SMS, and it is an essential part of a Part 145. So that's the conclusion of this module, and I thank you very much for participating, and I hope you learned a lot about 145, Part M, Part 21, and the basic regulation in the course of these 3 videos. Thank you very much.